Okay, as you know, the program is cut out. So solve for x. If f prime x is equal to g prime x, we worked out the derivative of f of x to give you 2x minus 2. G prime x is going to give you 3x squared minus 7. Because they want you to know, at which value of x does that, is that the case? So we see the two equal to each other. Okay? So 0 is equal to 3x squared minus 2x minus 5. Okay, so that gives us 3x and 5, x and 1. So it's minus plus. Okay? So x is equal to 5 over 3, or x equal to negative 1. Okay. So that will be the case on both graphs at that point. Okay, so if you take, if this is x at minus 1, can you see here somewhere? Can you see here the gradient here? The tangent will tangent is basically a straight line that will cut the graph at one point only. So if you take this, even though the graph is not drawn to scale, it almost makes sense that the tangent drawn at that point, if I bring that point down onto this graph, it has about the same gradient. Can you see that, people? Okay, if we're looking at 5 over 3, that is 1. 5 over 3, remember this was 1. 5 over 3 is 1 and 2/3, so it's approximately here. So if I draw that graph going through there, can you see it? Going through there, we're drawing that up, about the same there. Can you see that, people? The tangent is about the same. Which means to say the gradient at that point on the f graph is the same as the gradient at that point on the g graph. Okay, that is what that calculation tells us. Okay. For homework, I want you guys to do exercise 9, number 1. Okay, number 2 is very similar to number 1. Number 3, determine the equation of the tangent. We've done a lot of tangents. You guys now know how to work out tangents, no? Or you need more practice?
More practice.
More practice, okay, so you can do number 3 as well. And number 5, so we're just doing the odd numbers. 1, 3 and 5. I'll explain tomorrow again. Okay? In your second derivative, we're reading now on page 162. Page 162. So here in 162 we are told that the second derivative, just cut this quickly. Again, you guys can make notes of these units with these different concepts, okay? We're looking at the second derivative. There's the explanation on page 162. Here we're talking about the second derivative. So coming back again, what does the first derivative tell us? The first derivative, if we set that equal to 0, it works out our turning points. Okay, if the first derivative, don't you guys agree? Morning.
Afternoon, guys. I can see understanding. Mates, you don't even know what time of the day is it now. And I just compare it
Great.
to 8.
Great. No, I didn't sit with that.
Not yet. Okay, I'll show you.
I'll mark later.
Okay.
I'm waiting for my other papers, man.
It's there. I'm not going to touch it until she puts it in the camera.
Of one. Okay, the second derivative. Here we go. Okay, so we see the first derivative tells us about the. If we see the first derivative equal to 0, we're working out the derivative. Not so. And if the first derivative is negative, the graph is decreasing. If it's positive, the graph is increasing. Okay. Now the second derivative, and the first derivative is also your gradient. Not so. Right. Now we're reading about the second derivative. On page 162. It is possible to determine the stationary points of a graph and then discuss its concavity throughout the sketch, sheet. Okay, so we'll talk about that now. Let's just see what they say. Okay, well, let me show you what I understand by the concavity of the graph. The graph is, if it's drawn, I need more space here. The graph is drawn. Okay. Now, if I was drawing tangent to a curve, to this curve for argument's sake, and I draw the tangent here. Okay, the tangent is now a point graph, a straight line that's cutting the graph at one point only. Okay, which is at that point. If I draw the graph there, what you notice is that the graph is below the tangent. Not so. If I draw the graph here, the tangent there, what do you notice? The graph is below the tangent, not so. If I draw the graph here, the tangent, what do you notice here? The graph is below the tangent. And as long as the graph is below the tangent, we say the graph is concave down. Okay. Okay. So what happens is, on this side, okay, what do you notice here? The graph is above the tangent. And here, the graph is above the tangent. And here, the graph is above. And here, the graph is above the tangent. It's here somewhere between that it changes. Not so? So if the graph is above the tangent, we say this is concave. Concave up. So if the graph is below the tangent, we say that is concave down. So make that note. Okay, then we're going to read now what the explanation is. There's more than one way of explaining that. Concave up and down. Okay. Okay. Anything's off? write a detour, draw a detour on the side. The reverse of that, of course, going this way. But draw a tangent here. What do we notice? It will be concave. Up, not so. Concave up. And this should of course be concave down. And this point here, which is midway between the two, okay, the midway between the two is where the second derivative is equal to 0. And this is known as the point of inflection. Okay, but we'll read now about it. Okay. The point of inflection normally weighs 2 marks if it comes in. Unless they're asking you to discuss the concavity of a graph and stuff like that. It goes up until 4 marks. Okay. But we will do all of those questions as we go through the exercise. Or as I go through the exercise. No? I feel like I'm the only one working here, it feels like. No? But I might be wrong. I hope I am wrong. Okay. Right, let's read what they say. We are told it is possible to determine the stationary points of a graph and discuss its concavity without sketching. Use the first derivative test to identify and classify the stationary points. Now how do we do that? Determine the values of x for which f prime x equal to 0. So here we're working out the stationary point or the turning point. Not so. Then this is determine the sign of f prime x for which x is less than a, but closer to a for x is more than a, but close to a. So in other words, on either side of it. Okay? Then, if f prime x has the same sign for x is less than a and for x is more than a, then f of a is a point of inflection. Okay? If f prime x is less than 0, which means to say it's negative, for x is less than a. But f prime of x is greater than 0 for x is greater than a, then a and f of a is a local minimum, and f is concave up. If f prime x is greater than 0 for x is less than a, but f prime x is less than 0 for x is more than a, then a of f of a is a local minimum, and f is concave down. Okay. So in terms of the graph, this is what they are saying. Okay. I think to read your where the graph is concave up and concave down from the graph is going to be easy. Not so. It will be much easier. So do we need to know all this theory here? No, we don't. I don't think you do. Okay, so let's just pass this. Use the second derivative to determine the points of inflection and the concavity of the function. Determine the point of the points of inflection. This is how we determine the point of inflection. What do? Determine the value of the values for x for which f double prime is equal to 0. Then here they go down this tangent again. If double dash of a is equal to 0, determine the sign of, you don't need to do that. Okay, the reason why I'm just going past this is because this is, it doesn't come in the exam as they are explaining here. You understand? There's a deep understanding of concavity, which whoever's going to study maths next year, you will go into. Okay? But for now, it's 2 marks that this is based on, 2 to 4 marks. And we don't need to know this in this formula. Okay? So this we're skimming past that thing. And this is the graph I drew earlier on, not so. Okay, however, we say at this point, you see there, that's a point of inflection. If I draw a ruler, and I draw a tangent here, the graph is above the tangent, above. But if I draw here, just on the other side of this red dot, what do you notice? The tangent, the graph is below the tangent. So again, concave up and concave down. The question would simply be, for which values of x is the graph concave up? If it's concave up, we just say, well, if a was 6, x is less than 6. Where's the graph concave down? For x is more than 6. You understand? X is less than a or more than a in this case. And that's how it's asked. Or they would ask you to work out the point of inflection. How do you do that? Second derivative. Set it equal to 0. Substitute the x back into the equation of f of x. Alright. There's a long explanation there. But listen, if you are that kind of girl that wants to know all this stuff and want to write your book full and your maths book full and make it pretty and all of those things for no marks, then you can write this 2 pages of it in your books, no? Alright? Right, so now we're on unit 7. Sketch cubic graphs. That's unit next subheading. Sketch cubic graphs. And this is what you need to know. There's a good couple of marks in paper 1 denoted to the section. Okay. Sketch cubic graphs. It's normally like between 10 and 15 marks that this is based on. Okay. And this is also coming in your upcoming exam. So this is where we need to be. This is the last section. So for the rest of the week, we're going to look at the sketching of graphs. Okay. At least one section you guys can do well in. No, I'm joking. No, you guys are doing well so far. I should be saying that. No, you guys are doing well. Okay. Is this okay? People, which page are we on? 167. I feel like I'm talking a lot today. No? Yes, yeah. I just had to let you go home and read all of this stuff. You wouldn't do that either. Right. People, we're looking at the example on page 67. Sketch cubic graphs. Cubic graphs. So you can write this down. Have one y-intercept. Secondly, at least one x-intercept, but at most 3 x-intercepts. Many have stationary points, which are local maximum and local minimum point or points. May have a point of inflection, which is a stationary point, or which is a point of inflection. I'll show you that scenario now. So I'm just going to give you a chance to write that down quickly. I'm going to pause the video at this point. Okay, so tomorrow we will start with...
Your attention please, Nyasha in grade 12, can you please report to the office? Nyasha in grade 12, can you please report to the office?
Alright. People enjoy the rest of your day. Good morning, good afternoon class.